Everyone, and welcome to today's Physics Daily Booster. This is number 9 in our Paper 2 series, and it is on the advanced information for both foundation physics and higher tier physics. We are going to start the topic of P7 in our booster today. So, first thing we need to know then is when we are talking about energy, it is measured in joules. That has a symbol of a capital J. Hopefully, we remember a lot of these different types of energy store from Key Stage 3, if not the GCSE itself. What we can see then: chemical, thermal, kinetic, gravitational, elastic, nuclear, electrostatic, and magnetic. We need to know all of those different stores. There are some examples there in case you're not sure what would actually constitute one of those stores, and there is the related equation link on the right. One thing that's nice about this year is that we don't have to learn any of those physics formulas at all. They're all given to us on the data sheet. So realistically, that's less relevant this year than it would be in any other year, for the simple fact that if you read the question, it's going to give you a massive hint as to what formula you're going to be using from the formula sheet itself. But do make sure you know the names of the different stores as your minimum starting point. Obviously, energy occurs in these different stores, but we also can transfer energy between stores. And there are 4 key ways that we can do this: mechanically, electrically, heating by particles, or heating by radiation. Depending on the actual context, so which store is changing into what, and obviously in what way, that would tell us whether it would be mechanical, electrical, heating by particles, or heating by radiation. It's very much a case of look and see what the question tells you, and then you can apply the correct transfer to that setting. In terms of how we can calculate these transfers then, there are 2 kind of key formulas to be aware of. In terms of the mechanical transfers, that's going to be our work done calculation, so force times distance. And remember, the distance must be in meters. If we're talking electrical, then that would be energy transferred is power times time, remembering time is in seconds. So again, we're just being a little bit mindful of what units they give us in the question here to make sure that we're selecting the right formula first of all from the formula sheet, and we've done the conversions before we plug in the numbers. In terms of the law of conservation of energy, this would be something you learned way back in Key Stage 3. Energy cannot be created or destroyed, only transferred between different stores. So that's what we mean by law of conservation of energy. We're not creating it, we're not destroying it, we're just changing it from one store to another. Which brings us nicely onto the idea of carrying out energy analysis. Now, in order to do an energy analysis, we need 2 points in a given process. We then need to identify the stores that have more or less energy at those given points, and then work out what type of transfer occurred between them. So, let's have a little look at an example. So this is an energy analysis diagram, and it sounds fancy, but in reality we've got some boxes with lines drawn in them. This is our energy analysis diagram. So what we've got here is just a little race. So we've got the start of the race as our first point, the end of the race as the second point. In terms of the energy stores in the first point, our start of the race, we have got chemical and kinetic. Because at the start of the race nothing is moving, the kinetic store is empty, it's just an empty box. But our chemical store, the fuel for example, is almost at the top. Now what we're going to find is at the end of the race, we will have transferred energy from that chemical store to the kinetic, because as we cross that finish line, the object is moving, but it has less fuel. So what we're going to do is basically transfer some of that energy from the chemical store to the kinetic. The one thing to be mindful of if you're drawing one of these is you can't create or destroy energy. So our 2 boxes on the right there must add up to the same amount as was in the chemical store at the beginning. So just literally use a ruler just to measure it, just to make sure. Last thing to do is add in the way that we've changed it between those stores, and because we're talking about car in this case, it would be a mechanical change there. Now, what we find is the reality of the situation isn't quite like that. We are not transferring every single joule of energy from our chemical store into just the kinetic. So if you think about a race, it's not all going to end up with the car moving. Some of the energy from the chemical store ends up elsewhere. It's going to end up in the thermal store. So the reality is we should have 3 boxes here in order to actually show that some of that chemical energy is going to end up in a thermal store, because that can be friction, sound, air resistance, all of those end up in the thermal store then. If there are any parts from today's Daily Booster that you'd like to go through in more detail, there's the P7 playlist over on the channel. You will also have this in your revision guides, and of course do have a look at some of the past exam papers just to get a bit of a feel for the kind of questions that come up. Don't forget to join us again tomorrow for our next Physics Daily Booster.